Okay, time for more MS Paint drawings. This time we're doing the knapsack problem with dynamic programming. Here is the problem. Here is the maximum weight. And here are our potential items to take. Here are their weights. And here are their values. With dynamic programming, we're doing a bottom-up, actually, approach to this. We have this little graph here, or table. Here are the items we can choose. And here are the potential weight amounts that we can have, with a maximum of 5 weight and then a minimum of 0 weight. Think of it like if the weight left you can have. So like if we don't take anything up to here, we have 5 weight left. If we take stuff don't take anything up to here, we have 4 weight left, yada yada yada, and so on. So first we want to look at our kind of null case, which is we don't take any items. Well, if we don't take any items, that means it doesn't weigh anything, so we can take the item in the 0th weight spot. How much are 0 items worth? They're not worth anything. They're not even listed up here. Alright, we have 1 weight left. How much do we gain by taking 0 items? None. 2 weight left? None. 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 You don't get anything for taking 0 items. Now is where it gets a little bit more interesting. We have item number 1. Item number 1. How much does item number 1 weigh? 2. So can we take item number 1 when we have 0 weight left? No, of course not. We can't take anything when we have 0 weight left. Can we take item number 1 when we have 1 weight left? Well, it has 2 weight, so no, we can't. So when you can't take something, you want to look at the thing above it, the weight or the value of the thing above it, because you'd be technically taking that instead. So we get 0 from up top, we carry the 0 down bottom. That'll get a little bit more clear as we go on, I think. Alright, so we have 2 weight left. We want to pick item 1. Can we pick item 1? We can, because it weighs 2. So, we're going to do a little comparison here. We're fighting over this slot. I guess we should do this. We're fighting over this slot. And we want to know, alright, is it worth it to take the item that's above it? Or is it worth it to take this item plus, alright, you go back 1, 2, plus this. That sounds weird, and you might think there's a pattern there. Again, it'll become more clear as time goes on, but you're adding this because that's how much weight you have left over. Right now it doesn't really do anything because it's 0. But do we want to take 12 plus 0, or do we want to take 0? I think the answer is obvious, that we want to take 12 plus 0, which is just 12. Alright, so now we go to 3. Well, if we have 3 weight left, this is 2. We can obviously fit a weight of 2 within a weight of 3. So we compare directly above it, that's 0, and we compare 1, 2, up, back. 12 plus 0 is 12. So we're going to take the 12 because it's greater than this 0 up here. And again, we're going back 2 and then up 1 because you always go back the length of whatever you picked for the initial thing it fit in. Again, it'll become more clear as we get further along in the graph. And you always go up 1 after you go back the 2 or whatever. Okay, so 4, kind of the same deal with this. These first rows are normally simple. You compare to above it, 0, or 1, 2, above it. 12 plus 0 is 12. 12 is greater than 0. You pick it. And I think you understand for this. We're going to pick this. Now, for number 2, or item number 2, can it fit in a weight of 0? Probably not, but let's check. Well, it weighs 1. No, it doesn't fit. Alright, can it fit in a weight of 1? It can, because it weighs 1. It fits snugly. So compare. Alright, is this greater? Or is this plus this greater? Well, or I shouldn't say this plus this. Is 10 plus 1 over and up greater? Because again, we're going over 1, because that's the first thing that we could fit the item in. Well, 10 plus 0 is 10. That's great. That's a hell of a lot greater than 0. So we're going to take that. We're going to take 10. Alright. Now, can item number 2 fit in a weight limit of 2? Certainly it can, because it weighs 1. So we're going to compare, all right, 12 versus over 1, up 1, plus that. So 10 plus 0 is 10. 12 is greater than 10. So we're going to take the one above it. So we're going to take 12. All right, now we're going to do, can it fit in 3? It sure can, but there's a catch here because we're doing actually a little bit more sophisticated of addition because we're going to compare it to the one above it, and we're going to go over 1, up 1, and we're going to add 10 plus 12. That's 22 for those of you who don't know. And that is greater than 12. So we want to take the 22 because that's the better deal. So we're taking 22. Now we're going to compare to within 4. It fits, obviously. So we're going to compare, we're going to compare above it to 1 over, up 1, plus that. Again, we're doing that 1 because it's here. It's not a pattern of always going over 1. It's just where we could first fit in. So 12 plus, what are we comparing to? 10? That's 20. The fuck? Hey, I'm sorry, I'm looking at my notes. Oh, I got a little jumbled around. That's 22. 22 is greater than 12, so we're going to take 22. That's the better deal. We want all the money. And for this last one, item number 2, which has a weight of 1, can fit within a weight of 5. So we're going to want to look at it a little bit more in detail. Compare this number to 1 over, up 1, plus that 10. So that's 22 compared to 12. We want to take the 22. All right, number 3. It's going to get a little more complex as well as we go on. All right, 3. Can 3 fit in a weight of 0? Probably not. As you would believe it, it can't, because 3 is greater than 0. We can't fit in there. All right, now can 3 fit in a weight of 1? No. It can't, because 3 is greater than 1. But you might be tempted to say, hey, I'm going to put a 0 here because we can't take it. That'd be wrong, all right? Because whenever we can't take it, we just take the value above it. That's what we've been doing with these zeros this whole time. We've been taking the values above. They've just happened to have been zeros. So you're going to take this 10 here, and you're going to carry that down. Because again, if 3 can't fit, why don't we take 2? That sort of thing. That's the sort of thing that's happening. All right, now with respect to 2 weight, can we take item number 3? No, we can't. It's too big, so we're just going to take the item above it because we might as well get something for our trouble. Now 3, can 3 fit in there? You bet your ass, motherfucker, it can fit in there. So we compare 22 to the value of the item we want to take plus over 1. No, I'm sorry. Over 3. Because again, we're fighting over 3. And be careful not to do the patterns. Up 1. So we're comparing 20 plus 0, which is just 20, to this 22. 22 is better. So we're taking the 22. All right. Can 3 fit in a weight of 4? Yep, it certainly can. So we're going to go 1, 2, 3, because that's the first place we could fit it in, remember? That's the first place we could fit it in, so we go back that number up 1. So that's 20 plus 10. That is 30. Is 30 bigger than 22? Yes. Yes, it is. Now we're going to say, hey, I want to fit in 5 weight. I got 3 weight. Can I fit? Yeah, I can. So we're going to compare the one above it and 1, 2, 3, up. That's 10. Sorry, I'm doing math in my head. I was looking over at my notes as well. 30. Have I been doing this right? All comes tumbling down. Well, this is going to be 32 because we're going to add 10 plus the 22 here. I think I've been going back 3 when I meant to go 4 or 2. But it's going to be 32 because it's going to be 10 plus 22 is 32. 32 is greater than 22. So we do that. Yeah. All right, number 4. We want to take number 4. 4 is the size of 2. Can 2 fit in 0? No, it can't. So we take the one above it. Remember, that's what we're doing. Can 2 fit in the size of 1? Oops. No, it can't, so we're going to bring that 10 down. Can 2 fit in the size of 2? It certainly can, so we're going to put, hey, are we going to put 12 in there, or are we going to put 1, 2, up, this number, plus 15? Well, 0 plus 15 is 15, so we're going to carry 15 in here. Alright, now 3. Can 2 fit into a weight of 3? Yes. Yes, it can. So we're going to compare this number to 1, 2, up. 15 plus 10 is 25. 25 is greater than 22, so we're going to pick 25. Now, can it fit in 4? Yes, it can. That's kind of just how these things go. Is 30 better, or is 1, 2, buckle my shoe, 12 plus 15 better? No, it's not. It's like 27. 30 is bigger, so we're going to take 30. Now for the last one, can 2 fit into 5? Yes, it can. So is 32 better, or is 1, 2 up here? 22 plus 15 is 37. 37 is better than 32, so we can pick 37. So this is our final answer down here for the best value. This is the best value that you can get. Like, this works. That's the value you can get with what picking the best options. All right, you wonder, what are the best options? Good question, hypothetical person who's probably me watching this video later. Well, one, you're going to naturally take this one, because it was our best option. It was the highest in the bunch. So we took 4. All right, so I'll write this over here. We took 4. And then you're going to compare. All right, how many did you go back to pick that one? You went 1, 2, and you're going to look at this one. I'm going to make it a different color. That way we know we're just looking at this one right now. We're not saying we took this one. We're just looking at it, because you have to think, all right, where did this come from? Where did this number come from? Did it come from going back however many and up or whatever? Or did it just come from the one above it? As you can see here, it just came from the place above it. So we know we took the one above it. So we took 2 as well. All right, now where did this 22 come from? Well, we know that we went back 1 here to get this 22. And so we went, because you know the one above this one isn't 22. So we ended up taking this one as well. So we took 4, 2, and 1. That's a little kind of a confusing way of putting it, I suppose. But it's the way I know. And yeah, that should be all you need to know to do bottom-up dynamic programming solution to a knapsack problem.